Okay, students, now we are going to one more topic that is a Lagrange's interpolation formula for unequal intervals. In the previous classes, we have studied the equal intervals. Now we are going to study unequal intervals. Here intervals are not equal. That means let y is equal to f of x be a function which assumes the values in this form: f of x naught, f of x1, f of x2, f of xn, corresponding to the values. X values are like this: x naught, x1, x2 up to xn, where the values of x are not equally spaced. That is unequal intervals. Since n plus 1 values of the function are given corresponding to the n plus 1 values of the independent variable x, we can represent the function y is equal to f of x be a polynomial in x of degree n. Let this is the polynomial. F of x is equal to a naught x minus x1, x minus x2 and so on x minus x1 plus a1 times of x minus x naught, x minus x2, x minus x1 plus a2 times of x minus x naught, x minus x1 into x minus x3 and so on x minus x1 plus, this is the general term of the polynomial, plus an of x minus x naught, x minus x1 and so on x minus xn minus 1. Call this is equation number 1. Each term in the equation 1 being the product of n factors, like this, n factors, product factors 1, 2, 3, like this, product factors in x of degree n. Putting x is equal to x naught in equation 1. Wherever x is there, we are substituting x is equal to x naught. Then we get f of x naught is equals to a naught x naught minus x1. Here we are substituting x naught minus x1, x naught minus x2 and so on x naught minus xn. From this we can write in terms of a naught. A naught is equals to this term shifting to the left hand side, we get like this: a naught equals to f of x naught divided by x naught minus x1, x naught minus x2 and so on x naught minus xn. Then putting x is equal to x1 in equation number 1, and we get like this: f of x1 is equals to, x is equal to x1 means here all term 0, this will be this goes to 0, this a2 terms goes to 0, an terms goes to 0, we get only a1 terms. So f of x1 is equal to a1 times of x1 minus x naught. We are substituting wherever x is there x1 here, x1 minus x naught, x1 minus x2 and so on x1 minus x1. Again you write in terms of a1 is equal to f of x1 divided by x1 minus x naught, x1 minus x2 and so on x1 minus x1. And similarly like this, substitute x is equal to x2, x is equal to x3, x is equal to x1 in equation 1. We get like this: a2 is equals to, an is equals to f of xn, general term, f of xn divided by xn minus x naught, xn minus x1 and so on xn minus 1. Then substitute the values of a naught, a0, a1, a2 and so on in equation 1. We get y is equal to f of x is equals to, we are substituting a0, a1 value here. Then y is equal to f of x, x minus x1, x minus x2 and so on x minus xn divided by x naught minus x1, x naught minus x2 and so on x naught minus xn, f of x naught. Now this is the a naught value. A1 value is like this: x minus x1, x minus x naught, x minus x2 and so on x minus xn divided by x1 minus x naught, x1 minus x2 and so on x1 minus xn, f of x1. And put f of an value in the equation 1, we get x minus x naught, x minus x1 into x minus xn minus 1 divided by xn minus x naught into xn minus x1 and so on x naught minus xn minus 1, f of x1. This is called equation number 2. Then equation 2 is known as the Lagrange's interpolation formula. Then after this we go to the one simple examples. to use the Lagrange's interpolation formula to find the value of the function. Using Lagrange's interpolation formula, find f of 10 from the following data. The data is like this: x values are 5, 6, 9, 11. F of x values are 12, 13, 14, 16. Look here, the intervals are not equal. Here 16 minus 14 is 2. 14 minus 13, 1. This is 1, 1, here 2. So here x0 value is 5, x1 is 6, x2 is 9, x3 is 11. Like this, f of x0 is 12, f of x1 is 13, f of x2 is 14, f of x3 is 16. By using the Lagrange's interpolation formula, this is the Lagrange's interpolation formula. Already we know that the values of x0, x1, x2 and x3, and regarding the function values f of x0, f of x1, f of x2, f of x3, substitute here. So f of x is equal to x, write as it is, x1 is 6 here, x1 is 6, substitute, x as it is, x2 is 9, x as it is, x3 is 11, divided by x0 is here 5, x1 is 6, 5 minus 6, and x0 minus x2, x0 is 5, x2 is 6, x2 is 9, 5 minus 9, and x0 is 5, x3 is 11, and f of x0 value, look here, f of x0 value is 12, substitute f of x0 value is 12. Like this, substitute the values here, x0, x1 and so on, will get in this form. Here f of x1 is 13, f of x2 is 14, f of x3 is 16. Wherever is there x0, x1, x2, x3 value, substitute f of x0, f of x1, f of x2, f of x3. After this, we want to find the f of 10 value, So putting x is equal to 10, wherever x is there, here x is there, f of x, left hand side, 4 times of, here x is equals to what? 10. 10 minus 6, 4. 10 minus 9, 1. Then 10 minus 11, minus 1. And denominator, 5 minus 6, minus 1. 5 minus 9, minus 4. 5 minus 11, minus 6, 12 as it is. The same like this, what you done in the first term, we have to do other 3 terms also, we get in this form. Then after simple mathematics is there, after simplification you will get 14.666. Okay, next we going to the one more formula, the concept of divided differences. Let the function y is equal to f of x be the given at the point x0, x1, x2 and so on xn, which need not be equal spaces. Here is also f of x0, f of x1, f of x2 and so on f of xn. Denote the n plus 1 values, the function at the points x0, x1, x2 and so on xn. Then the first divided differences of the function f of x for the arguments, x values are called arguments here, x0, x1 is defined as f of x0 minus f of x1 divided by x0 x1. It is denoted by like this, f of x0 x1 is f of x0 minus f of x1 divided by x minus x1, or it is, we can denote in this symbol. Actually we know that forward difference, that is delta we cut it in between there, that is divided differences, this one, f of x r by x0 x1. Therefore f of x0 x1 is equal to f of x0 minus f of x1 by x0 minus x1. Similarly we can define like this. How to define f of x0 x1 is f of x0 minus f of x1 divided by x0 minus x1. Like this we can define the other points also, next points. F of x1 x2 is equal to f of x1 minus f of x2 divided by x1 minus x2, and so on. Like this we can. Then the second divide differences of the arguments x0, x1, x2 is defined like this: f of x0, x1, x2, three values here. Then that is f of x0 comma x1 minus f of x1 x2 divided x0 minus x1. Similarly, not only here we have second divided differences, we go to the up to n divided differences. Similarly, the n third differences like this x0, x1, x3 and so on. f of x0, x1, x2, x3, f of x0, x1, x2 minus f of x1, x2, x3, x0 minus x1. Note, the first divided differences are called the divided differences of order 1. This one, f of x0 comma x1 is equal to f of x0 minus f of x1 to x0 minus x1 is known as the divided differences of order 1. Suppose it is 2 is there, second divided differences are called divided differences of order 2, and the third is there, divided differences of order 3, 4, 5 up to it is, we can say n it is. Now let us write the how to prepare the divide difference table. We know that in the previous classes how we can prepare the forward difference table, backward difference table and central differences. Now we are going to form the divided difference table. Arguments are same here. X arguments x0, x1, x2, x3. Entry value f of x is f of x0, f of x1, f of x2, f of x3. This is the first order, f of x0, x1, f of x1, x2, f of x2, x3. This is the second order. This is the third order. Then look here, in the first order we have a 2 points x0, x1, x1, x2, x3. Here in the second order 3. In the third order we have a 4 points. So this is the actually divided differences table. Now let us move on to the one example. Prepare the divide differences table for the following data. X values are, these are the argument values. Arguments values are 1, 3, 4, 6, 10. And entry values are like this: 0, 18, 58, 190, 920. Then find the divided difference table. Arguments 1, 3, 4, 6, 10 and entry values are 0, 18, 58, 192, 920. Then how to find the that is the divide differences f of fx is 0 minus 18 divided by 3 minus 1. Look here, entry we 0 minus 18 and arguments reverse 3 minus 1 minus 3, that is 0 minus 18, 1 minus 3 is minus 18 divided by minus 2. Minus minus get cancelled, 2 9s are 18, like this. Then 58 minus 18 divided by 3 minus 4 will get 40. Then 58 minus 190 divided by 4 minus 6. Very simple method is 61. 190 minus 920 divided by minus 6 minus 10. 182.5. Like this we can also find second one. Second, how will we get? 9 minus 40 divided by, we take this here 1 minus 4, already 3 is there, no? 1 minus 4. Then 9 minus 40 is minus 31 divided by minus 3. Minus minus get cancelled. After we simplify, 10.33. Here 40 minus 61. 40 minus 61 divided by 4 is common. 3 minus 6 rate. Third, second order, it is very important. Then after simplification we get 7. 190 minus 926 minus 10. Here 61 divided by 182.5. 4 minus 10. 10.25. Then next we go to the third order. 10.33 minus 7 divided by 1 minus 6. 1 minus 6. Then after simplification we get 0.660. Then 7 minus 10.25 divided by 3 minus 10. 0.4643. Again this minus this, then 1 minus 10 will get 0.14 This is the how we can find the prepare of the divided differences table. I will explain once again second one. First differences are divided differences are very easy, but second divided differences we have 9 minus 40 divided by 1 minus 4, 1 minus 4. Then this is like this only, 40 minus 61 divided by 3 minus 6. Then next one, 61 minus 182.5 divided minus, like this other orders also we can find it. Now this is the important how we can find the divided differences table. Next move on to the one more important method, that is Newton's general divided differences formula, or it is also known as the Newton's interpolation formula for unequal intervals. Let y is equal to f of x, takes the values f of x naught, x1, xn correspond to the arguments like this, x naught, x1, x2, by defining f of x, x naught, f of x minus f of x naught divided by x minus x naught. This is equal to f of x. Then f of x is, we can write f of x naught plus x minus x naught, f of x naught, f of x, x naught. The same formula we can write in this form. You are writing in terms of f of x. F of x, x naught is multiplied by x minus x naught, and minus f of x, take left hand side, shift, you will get plus f of x naught. This is the first. Second means similarly f of x, x naught, x1, f of x, x naught minus f of x naught by x1 divided by x minus x naught. Again you write this one in terms of f of x, x naught, will get like this, f of, this is multiplied by left hand side, f of x, x naught, x1 into x minus x1 is here, and this term you should taken in the left hand side, will get here, it is not x, it is x naught minus x1, x minus x1. Substituting in the equation 1 these values, what values here, f of x, x naught, x1 values are, f of x naught values are, substitute here, we get f of x is equal to f of x naught as it is, x minus x naught, this values is here, substitute. Then next we want f of x is equal to f of x naught, x minus x naught, f of x, x naught, then multiplied by x minus x naught is multiplied by f of x naught, x1, x minus x naught is multiplied by x minus x1, x minus x naught is multiplied by f of x, x naught. This is called equation number 2. This is the unneutral intervals. Now proceeding in this way, we'll get the proceeding in this way, we'll get f of x is equal to f of x naught, x minus x naught, f of x naught, x1, x minus x naught, x minus x1, f of x naught, x1, x2, and so on, and up to write in general formula. If f of x is a polynomial of degree n, then the arguments are like this, x, x naught, and so on, xn. Here n plus 1th difference, hence the equation 3 becomes, we write the general formula of this, f of x is equal to f of x naught plus x minus x naught, f of x naught x1 plus x minus x naught, x minus x1, f of x naught x1 x2, plus and so on, x minus x naught, x minus x1, and so on, x minus x1 minus 1, f of x naught x1 xn. This is called Newton's divided difference interpolation formula for unequal intervals. Now this is the important formula. Now using this formula we can find the value of the function, some particular point. Use Newton divided difference formula and find f of 6 from the following data. The entries are like this, arguments 5, 7, 11, 13, 21, x values, f of x values from the divided difference table for the given data. In the previous example we know that how to find the divided differences. Here 392 minus 150 divided by 7 minus 5. In the previous one what you have did, 5 minus 7 we did, but here 392 minus 150 divided by 7 minus 5. 392 minus 50, 7 minus 5, that is simplification 121. 1452 minus 392 divided by 11 minus 7, then simplification will get 26.5. Again, like this we can solve the 9702 minus 2366 divided by 21 minus 13 will get 917. So like this we can find the higher order also. Higher order, it is important. 265 minus 121 divided by here 11 minus 5, 11 minus 5, 24. Then next 457 minus 265 divided by 13 minus 11, 13 minus 11. Then next 917 minus 457 divided by 21 minus 11, 21 minus, here also 13, 11 minus 5, then 13 minus 11, 11, 7, 13 minus 11, 21 minus 11. So after simplification we get 24, 32, 46. In third order, central differences unequal. 32 minus 24 divided by 13 minus 5. Then 46 minus 32, 46 minus 32, 21 minus 7. This is 21 minus 7 is equals to 1. Then fourth order is 0. We have the formula is this one. F of x is equal, f of x naught is here, f of x naught is 150, then x naught is 5, then f of x naught x1 is 121, f of x naught x1 x2 is 24, f of x naught x1 x2 x3 is 1. Now all the values are known. F of x naught values, what is our x? X is 6 here. We substitute x is equal to 6 and x naught is 5. F of x naught value, f of x naught x1 x2 x3 will get it. Substitute in this formula. After simplification you get f of 6 value is 252. Now these are the some examples. I given 5 examples using the Lagrange's interpolation formula and Lagrange's interpolation formula. Then try to solve these problems. Okay, now we meet in the next class.